If you ask 10 different data analysts to describe to you the different types of data analyses, you will get 10 different answers. So the truth is that you cannot distill all of the different types of data analysis into perfect, mutually exclusive categories. But I wanted to give you my perspective so you can have a general framework of how to think about the different types of analysis. Our first and most foundational type of data analysis is what we would call descriptive or diagnostic data analysis. This type of data analysis focuses on summarizing and describing the main characteristics of a dataset. It aims to identify patterns, trends, and relationships in the data, and to provide a clear and concise picture of what the data looks like. Examples of the metrics you might use when conducting descriptive data analysis include things like central tendency measures like the mean, median, and mode to describe the center of a data distribution. Spread measures, calculating the range, variance, and standard deviation to describe the dispersion of a data distribution. Aggregate measures like summing and counting your data. Trends in the data like notable increases and declines in certain metrics. I like to bucket in diagnostic and descriptive analyses because they are very similar. While descriptive analysis aims to describe what happened, diagnostic analysis aims to describe why something happened. However, very often, diagnosing why something happened is just the result of one or more descriptive analyses, brought together to tell a story and therefore creating a diagnostic analysis. This is why I group them in the same bucket. Diagnosing a problem can often be done through descriptive analysis or analyses. The second type of data analysis that we will talk about is predictive data analysis, which is the type of data analysis which aims to make predictions about future events based on past data. It involves using statistical and machine learning techniques to build models that can be used to make predictions based on new data. Examples of predictive data analysis techniques include regression, classification, forecasting, and neural networks. The third type of data analysis that I would like to discuss is causal data analysis. Causal data analysis is used to establish cause and effect relationships between variables. It involves identifying the relationship between one or more independent variables, the variable that's being changed, and dependent variables, the variable that is being affected by the change. Causality is commonly established through randomized controlled trials, which in the context of software is typically called an A/B test. These experiments rely on being able to split your population into a treatment and a control group. However, there may be times when creating a true treatment and a true control group is not possible. And this is where analysts might use Bayesian structural time series models to forecast a counterfactual. A counterfactual is simply what would have happened if the change had not been made. Data analysts will typically spend most of their time conducting descriptive analysis, and the predictive analysis is mostly left to the data scientists in the organization.